holding off the main talk this evening. Just some facts. So we just were discussing when the meetup in London was starting. So it started in July 2014. I assume you beat us to that. I believe you're on it.
I don't see that.
Yeah, because David is organizing the meetup in London, or started organizing it. So until now we have 2,300 some members, 38 meetups already, and another one coming in December. In the early days I typically ask this question, but I do it once in a while. For whom is this the first microservice meetup? Wow, still half of the room. This is amazing. And this is also why we have that many members, because there's a lot of churn after the first meetup and the second one. Then just going through, we started in 2014. Stefan Tilkov, for example, was here. James Lewis, who co-coined the term microservices, was here also in 2014. I don't remember. Hi Wiener, this was Christian Digger. Oh, what's that? Yes, on home turf I can speak whenever I want. Then what we see there, Sam Newman, Phil Casado, a lot of famous people. Eberhard Wolf showing up, Richard Rogers, Gregor Hoppe, Bojan Dimitrov, Uwe Friedrichsen again, he's the first speaker to appear 2 times. Daniel Bryan also from very nice man. Yes, he is. He was here. Fred George, also one of those original microservice. Actually, this was the work exported to PowerPoint. Nevertheless. Vaughan Vernon, he just showed up on a short notice. This was still one of the biggest crowd we ever had. Last week Eric Dönenberg was here. This is how you look from here. Then at one meetup, Adrian Cockroft just dropped by. I dragged him along from OOP because he was just around, and then he did a Q&A afterwards with Eberhard Wolf. He's one of those guys who knows a lot about microservices and transformation, as being the CTO of Netflix, or was the CTO of Netflix. And to finish it up, a short round of applause for Autoscout, who is paying for the venue, for the beer, and for the pizza, and by the way is hiring. Also, as I said, the last week, it's getting even better. They're also hiring now a chief architect. So, hint, yeah. So this is about all I wanted to do in my retro. So I come talking to get that one settled. David Dawson from Manchester. I first noticed him as co-organizer of the meetup in London, which inspired this meetup, and also, I believe, the first microservice conference, the Muon, or Muon, how do you pronounce it?
However you want to.
Okay, in London in end of 2014, and there I saw a talk from him, and since then I kept him in the back of my head. And when you started going public with your microservice framework, I asked him whether he would like to talk about this one, and from there on I take over to you, and you introduce yourself and enjoy the meetup. Thank you.
Thank you very much. So just so you know, I can't see you, because the nice man at the back has decided that it's okay to blind people, and apparently that's not. Don't say that. Okay. No, apparently that's the way it should be. So if you have a question, it's just a disembodied voice, and that's okay. If I don't look at you, that's the reason why. I just have no idea where any of you are. Right, so I'm going to do a talk on a project called Muon that I've been working on for quite a long time, probably far too long than is healthy. But I've been trying to understand the problem. I've been grasping towards an idea for several years. And I think I've actually come up with a way of describing what the problem is. Possibly even a solution, but I think I've understood the problem at last. Even though it's been several years, and that's far too long to spend on a single problem. So I'm going to talk to you about that. So my name's David Dawson, as you probably know. I do lots and lots of things. I try and be as polyglot as I can. I don't speak German, but I don't just speak English, so I'm not one of those bad Englishmen. I program in many languages at the same time, and I enjoy that, and I think that's a good thing to do. I've been doing lots of things on Internet of Things stuff, so down in the proper kind of microelectronic stuff. And learning embedded C is something I feel you should all do. You'll hate it, as do I, but it teaches you that higher level languages are there for a very good reason. So yes, I do recommend you do that, but even if you do just once. I've also set up the Microservices user group in London, and I don't mean to brag, mine's bigger, but only very slightly, so hey, what are you going to do? And then Muon project, which is what I'm going to talk to you about. So these are some of the things I do in pictorial form. That's my desk at the moment. I have a bunch of kind of microelectronic stuff that we're working on. Got some very interesting, I find it very cool. Doing soldering is very therapeutic. Melting metal with a hot piece of metal is really cool. Apart from that, one of the things I'm really into at the moment is Rust. So if you've not come across the Rust language, I recommend you have a look. It's a, who's ever programmed in Go? Imagine I can see you. Okay, I'm going to assume some of you have put your hands up. Thank you very much, by the way. One of the things that Go pitched itself as was, it is a systems language. They lied. It is not a systems language. It has a runtime library and a garbage collector, so it is not a systems language. It's a good language, I'm not saying it's not, but it's not a systems level language. The question is, could you program a kernel in Go? The answer is absolutely not. Rust, that's not the case. You could program a kernel in Rust. It is a proper systems language, but one that actually you can treat as a very high level language as well. So I love Rust, it's brilliant. I'm not here to talk to you about Rust. I am here to talk to you about something else. So given the theme of the meetup, microservices, I have a question. And this is not rhetorical, I want an answer. What is this thing that we call a microservice architecture? Please give me some answers. Who would like to be brave? Anybody? Christian? What's microservices? I don't mean to put you on the spot, but I do.
Yes, it's an architecture pattern, it's not an architecture in itself. And I believe it's about autonomous, loosely coupled systems and services. Okay, that's a good word. Yeah, so that's definitely some of the things. Some of the other things that you might start being thrown around, might hear being thrown around, are words like small web services or small services with a REST interface. So done right, which I think is hilarious. There's things like bounded context. Is a phrase that people pull in if they've looked into DDD. There's lots of different ways of defining this thing. Everybody actually seems to have their own definition of what the microservice architecture is. So we were talking kind of when we first set up our respective meetups around the same time. Part of the motivation for that was people were throwing out ideas as to, oh, we're doing microservices, it's great, it looks like this. And then there was a set of kind of articles and books that came out. So some by, say, Martin Fowler was one of the kind of interesting ones that came around. He sat on the small web services side of things, very much so, and then added other things around it. What I've noticed is that actually, if I were to take all of the things that you believe microservices are and line them up in a massive spreadsheet, imagine that we're doing some data crunching, massive. These are all the things that people that believe in microservices. These are all the people. These are all the common things you find that there aren't any. There are no common things that you and everyone else in the room believes defines microservices. It does not exist. This is my discovery. So I've asked lots of people this question. In conferences, I've asked all of my clients, I've asked all of the people who go to the London user group, I've asked kind of hundreds and hundreds of people. And there is no common definition of what microservices are, which I think is kind of odd, given that kind of how much effort is spent on building microservice systems
when we don't actually have a prescriptive way of saying, this is microservices if you do X, Y, and Z. That doesn't exist. So what do? So I looked into this more deeply, and actually I did detect that there was something that everybody agrees on. Two things, actually, that everybody agrees on, but they aren't quite what you imagine. So the first one is isolation. So everybody has the idea that when you're building microservices, we have bits, and they are separated by something. It might be a network, probably is, but it might not be. But there's definitely some form of pulling apart involved. And the other one is what I can only call aspiration. So this is an English word that kind of, it has echoes of you're grasping towards something better. You're reaching towards something that's good, but you have to reach. And so it's the only way I can describe this. It's the feeling that, yes, we will pull our system apart and the world will be better. We've no idea how, but it will be. We're completely sure. That's what Martin Fowler said. Now, this may or may not be true, but that is what people believe. And so I would say, I am a long-term consultant. This is totally amazing. You know, as a consultant, this is brilliant. I can sell this. I can rock up to any one of your businesses and I can charge you X thousand euros and you would feel good at the end of it. And all I've done is said stuff that makes you feel good, and that's it. As a technologist, which is what I truly think I am, this is awful. You know, I think you'd all agree. This is not the way to build software. You know, unless you're doing it right if you do X, Y, Z, it's not real, really, is it? So this then led me to the thinking, well, people almost universally say, well they did anyway, the microservices architecture. So, we have a question. What is architecture? Who would self-identify as a kind of architect type person? Be brave, it's okay. We're among friends, most of them. So we've got half a dozen. So, that time. I managed to log out of Wi-Fi and it did bad things. So I am going to disconnect. So, software architecture. Now this is a word that we have stolen. I think we have to be upfront about that. This is not a word that we created. We stole it from construction. It has a very definite meaning in the world of construction. It's very well defined. In software, less so. So we have to figure out what this thing is. Here's a question. Is it the same thing as software design? What do we think? We have a definite no at the front. Do we have any yeses? Some non-committal maybes? No one's brave. It's okay, I'm not out to embarrass you, that will just happen naturally. Okay, so I would say, no, they are definitely not the same thing. And I can fairly easily prove that to be the case. So if you look through a piece of software, you will find that there are design decisions absolutely everywhere. You look through a piece of code and you say, right, they chose to use this construction rather than this construction. They could have chosen either, but they had to pick one, and so they did. And so it happened, so happens that they came back from a heavy lunch, and so they did the easy one, because they were kind of sleepy. And that, I think, speaks volumes, because 2 weeks later, maybe they came in after a gym session and they took the hard approach, and it was good. But they could have chosen either. So if you were to kind of design the same piece of software a few months apart, you'd end up with something totally different. But there is something else as well beyond the design. And so we have, what I would say, we've got limitless options for design. You know, there are no limits on the amount of design decisions that you can make. You could go through the same piece of software, change every single design, and it still work exactly the same way. So design is limitless. But architectures, you know, we look at our architectures, and there are only a few. Maybe it's dozens, maybe it's hundreds, doesn't matter. There is a limited number. We even give them names. You know, we say an N-tier architecture, message-driven, SEDA, you know, these kind of things. These are the software architectures that we try and implement. And so, from a pure cardinality point of view, just simple counting, design and architecture are not the same thing. One is unlimited, one is limited. So they're definitely related, not the same. So we have the question, what is architecture? What do you think? Still unsure? So when I think of architecture, I would say it's not the solution. Design is the solution. So architecture is something else. It's the route to the solution. It's a set of constraints to the kind of guide the design decisions. So a good architect, in my view, they stop their developers that they're looking after, they stop those developers making bad decisions, and they help them to make good decisions. They don't make the decisions for them. They simply put the guides in place. So they put in constraints, they create a good mental model, kind of a good approach, a good way of thinking about the problem, so that the design decisions that are made are correct. Now, those kind of phrases I know from another field, which isn't software. And I think it's interesting, because all of those phrases, a good mental model that you use to approach a solution, I could say, well, actually, that's philosophy. This is what philosophy is. It's a set of mental models that you use to engage with the world and come up with kind of solutions to problems. And so I would actually very much argue that the software architect is actually the software philosopher, and that fits just as well and probably better. So I view myself as a software philosopher at heart, which I think is great. It's good. And so that leads me to a question. What is your philosophy? Now, have you actually thought about it? I would encourage you to. A little bit of reflecting on what you do and why you do it is a good thing. And that then leads to, well, actually, if we have microservices architecture, surely this fits just as well and probably better. This is something that I can get myself behind, because fundamentally this is what it is. It's a software philosophy. It's not prescriptive. It's descriptive. We can recognize it when we see it, but we can't kind of tell you exactly the steps to get there. We simply put some constraints in and say, well, we distribute and we do these and we do that. We're emphasizing change. That's what microservices has been about from the beginning. We want to be able to change our things without getting stuck in this monolithic mess that people are so afraid of. And so fundamentally, this is it. This is what microservices are. Now, that's great. That doesn't help you build a system. It's not a design style. And so you do need a design style to kind of tell you what your decisions should be. What is the prescriptive way of building software that you're going to use? And so that's kind of where I started to tread. Because I think I came to microservices in 2014, and this is my thought straight away. I've always viewed myself as fairly philosophical and enjoyed that. Microservices didn't quite tell you what to do. I did notice, however, that people were starting to do something, which was, I'll get into. And so I heard about this thing, similar kind of time, Reactive Systems, the Reactive Manifesto. Did you ever read has anyone heard of Reactive? Most people, good. So did you ever read the first version of the Reactive Manifesto? No. Good, it sucked. The second version is much better. But I started to come across this thing called Reactive. So I kind of asked, what is this thing, this reactive thing? I think it helps to understand what it was. It was, strangely, hilariously actually, it was a reaction against something else. And so they tried to define it in terms that were contrary to the thing that was there before. So we have to ask that, what is reactive not? Now, I have a particular dislike for RPC, and I would say that HTTP is here. Who's building a microservices system here? Okay, I'm friendly. Who's using HTTP? Same hands. This is for you. So, HTTP. I'm here to tell you, HTTP is RPC dressed up. That's it. It is not clever. It is request, response. You can call it REST all you like. I don't care. Request and response is RPC. No more, no less. Now, I'm not saying that HTTP is bad in and of itself. As a protocol, it's very good. It does the job it was designed to do. What I don't like is the effects that it has on your designs, the way that it makes you think. And that's kind of a problem in thinking, is what the microservices architecture should be guiding you away from. And I'll show you what I mean. So imagine you have a system. We have an HTTP request coming in here. We have an orders service. Makes sense. You know, kind of you have orders in the system, you want an order service to manage them. Absolutely. Now, your order service, it has some dependencies to be able to do its job. So you don't want to keep products with the orders. That wouldn't make sense. You know, you want to split them apart because we're separating, and kind of as a good design discipline, we want to split these things up. That does make sense, sure. We also have authorizations and user information that we'll need, so we've got 4 services, each with their own database. Now imagine you want to get some information from the warehouse on where your system is up to. Then you'll need to have some fulfillment information, so you need a fulfillment service. So here we have a small microservices system, 5 services, several databases. And this is one of the things that is sold as a good thing. Each microservice should have its own data. The reason being, it should be autonomous. You should be able to change it as needed. And from a certain point of view, this certainly does that. The problem is this. What happens then? You know, we have a network break. Orders can no longer speak to its dependencies. What happens now? Is orders, in fact, autonomous? I would say probably not. If you were to implement some of the nice patterns, like a circuit breaker, so this is essentially the problem that a circuit breaker is designed to solve, so we're told. What you'll end up with is this. You know, you'll end up with intelligently default information that actually is totally bogus. You know, kind of this, sending that back to a user, is worse than useless. This will confuse them and you'll get complaints. And if you were to just send an error back, then you'd probably get less complaints. So this is not a good thing, but that is what you will end up with if you follow much of the received wisdom that we now have about microservices. Not good. So fundamentally, orders, it does rely on all of these other things, which has a very poisonous effect on your system. Because you know, if each one of these services has 5 nines uptime, which is what you want, you know, you want good uptime, then what you end up with, because this in fact depends on all of the others, you end up with a multiplication effect in terms of failure. So you no longer have 5 nines uptime. I'm very sorry. You are guaranteed 4 nines uptime. That is the best you can get with 5 services in a web, in a dependency web. And it's important to say, the only reason you have this is because you chose to use a form of RPC. Whether that's HTTP, gRPC, any of the others, doesn't matter. And it doesn't matter how good the implementation of that technology is. The fact is, you, in the way that you've designed your system, have built a dependency web. And that's the real issue. So I don't hate HTTP because of that. Sorry, I don't hate HTTP because it's HTTP. I hate it because this is what developers end up doing. They create webs of dependencies that will just hose your uptime and cause all kinds of rampant network effects. It gets fairly ugly in a large system. So you don't want to do this, and you know, fundamentally this becomes extremely fragile. When you try and scale a dependency web, it becomes nightmarish. You don't want to do this. So each one of the hops, if you're using HTTP, is 20 milliseconds minimum, just for negotiation time. So that's, if you add that on, kind of, so in this one we had 3 hops, so 60 milliseconds just for negotiation. No data traffic at all. That's becoming noticeable for a human. So that's not a good thing. Big one, and this is where the design problem comes in. Data fundamentally is relational. So product information needs to relate to order information, which needs to relate to users. It has to. That's the way you're going to query it. That's the way you're going to present it. So why have we split this data apart? Why have we done that? You know, it makes sense from a kind of a received wisdom. You say, well, we need to split up. How do we split up? Let's do it on entity. That kind of makes sense. It doesn't make sense. It's a bad way of splitting the data up. Because when you need to query it, you'll end up creating what somebody brilliantly called inner join over HTTP. And I wish I could take credit for this. It's an awesome statement. But it describes the problem, which is you have to do a query across several different data stores, and you're using HTTP to do that. You know, have you any idea how many thousands of HTTP calls it takes to take down a system? I know. You know, I've seen it happen, and it ain't pretty. So you don't want to do this, because you will end up with data silos, and data silos are your enemy. And if you're building a microservices system, this is probably what you're doing. This is probably where you're headed. And so this makes me terribly sad. So this is what I've been watching the industry raging on about. And you know, is it good? No, it really isn't. Sorry, guys. And so this is what people are building. So what are we going to do? Well, since we're all here, I'm going to talk about reactive as an approach. Now, the problem with reactive is we actually have more than one reactive. And it's kind of embarrassing that we've ended up with this situation, but this is where we are. So when I talk about reactive, what I mean is reactive systems. This is where you implement the Reactive Manifesto. You try and use the architectural principles in Reactive Manifesto, which is to build systems that are responsive, resilient, elastic, and message-driven. And then you do that on a large scale. Now, this is an architecture. So just like I said before, it's a philosophy. It's a set of guiding principles. So that means that every design decision that you make, you line it up against these and say, is this message driven? Yes or no? That's fairly easy. Is this elastic? Is it resilient? And so you can take your design decisions and view them through this architecture, through this philosophy, and say yes or no for each one. And it's a good measure, it's a good yardstick to do it. So I recommend reading the current Reactive Manifesto. It's actually quite good now. Don't read the old one in Git history, it's not very good. Now, the other reactive, which is probably the one that you hear about more, is reactive programming. So this is something that essentially came out of a bunch of research from the 70s, where you had what amounts to data flow. So flows of data, and you want to do transformations on the flows of data, and update a piece of information here based on changes that happen here. And so you kind of map that as a form of data flow between the two, so that the two will update automatically. I'm not talking about that. This is where you start to look at things like RH Java and Akka streams and other technologies like that. So it's a very good thing. It's a very good approach. I recommend doing it, but that's not what I'm talking about. So yeah, fundamentally it's about implementation. So you can see the two as very closely related, because they are. You have a reactive system where you have lots of components. They're talking using messages. Within each of those components, you want to be able to process that data, move it around, transform it, do those kind of things. And that's where reactive programming comes in. So inside each of those components, you would start to use something like RxJava or RxJS or any of the other reactive programming libraries, depending on what your runtime is. For the gaps in between the services, that's the realm of the reactive system, message-driven system. And it's a good place to kind of look at, because that's where people will generally throw HTTP and forget they've done it. So, this is not immediately straightforward. When you're building a system like this, certain things start to appear. You have to start thinking about things in a different way. And this is, I think, the big benefit of reactive. It forces you to think in a different way. But unfortunately, that hurts to be able to do that, because you have to let go of the way you think about the systems and think about data. So the idea that you can take the orders entity and have that appear in a single place in your system, you have to let go of that idea. That is not what a reactive system will be. But actually, having the orders data appearing just one place in your system is not scalable. That's an RPC-inspired idea. And so you do need to let go of that anyway if you want to build a system that is kind of maintainable, scalable, and isn't going to be a dependency web. So these are the kind of things to start to discuss, this kind of reactive system approach. And so just to kind of skip through a few potential designs or kind of approaches to this kind of thing. The fundamental problem, you have some data in one service, you want to get it in another service. This isn't going to change. This is always going to be the case. The real question is how do you do that and what do you do it for? When do you do that? So if you do RPC, well, service A simply calls service B inbound, gets the data, sends it back. So there, this service and this service have to be aware of each other. They have to be up at the same time. This has to be able to create the data and give it back at the time that this is asking for it. So all of these things, actually, they couple these services together in terms of data, in terms of schema, in terms of time. And it's all of those couplings that cause the dependency web problem. So this is fragile. We have angry dragon, don't go there. Some of the other approaches. Maybe you could actually store a copy of the data in service A and have some synchronization mechanism that will materialize the view that you want of that data in service A. The benefits of that is that service B doesn't need to be up when service A wants the data, it's already local. You don't have the network hop anymore because the data is being synchronized. This becomes eventually consistent, so it might not be immediately consistent. Now, people get scared by the word eventual consistency, and it's a misunderstanding of what eventual consistency is. Eventually consistent is always consistent, so long as you involve time. If you can ask the question, what is the data as of 2:32 this afternoon? You will always get the right answer in an eventually consistent system, always. Or you will get the answer, I don't know. So this is what you need to do. If you're building an eventually consistent system, always include time. So this is one approach. It gives you really good performance, way beyond what RPC can do. Some of the other things that you need to start thinking about maybe, possibly you need to stream data between services rather than doing RPC calls. Some of the things that will start to appear when you're streaming is buffering. So if you have data that has to buffer in any of your services anywhere, this starts to create a problem. You end up with unbounded resource consumption and all kinds of terrible things. The solution to that is to allow the client to manage that, which is something I'm going to talk about in depth later. Looking into event architectures, I'm not going to spend any time on event architectures today, but it is one of my favorite things in the world. Other things. So there's lots of things that you can do with reactive systems. And this is the thing that you need to start thinking about is how do you open your mind to the possibilities? Now, this is not a resource-driven world anymore. You know, if the only kind of things that you can think of are resources, then everything will look like a resource and you'll end up with a dependency web again. So you need to think about things not in REST terms. Move away from that. So, we have lots of different things that we could use. Some technology that you could use to manage state. We have things like Akka. Who uses Java? Yeah, most people. What do the rest of you use?
JavaScript.
JavaScript. It's okay. It's getting better. Anything else? Anything else? .NET. Okay. So there's lots of things that you could use. These are some of the example technologies you could use to manage states. Now, an interesting question. By adopting Reactive, in terms of a system, building a system using kind of these message-driven, resilient, elastic, all the rest of the principles, what's gone? No, this can't be a magic trade-off that's all upside, surely. And you're right. I'm glad you mentioned that. It's not a magic trade-off that's all upside. You have lost something big, and it is a very big thing, which is this guy. So the concept of the API. Now, in our world, kind of the world that you're inhabiting right now, the RPC HTTP world, APIs, you mean HTTP. So when you say we're going to build an API strategy or whatever it is, whatever phrase you use, you're talking about HTTP. And that's not a bad thing, because when you're talking about HTTP APIs, what you're actually talking about is all of these things that go around it. It's not the HTTP, it's the stuff that's stitched on. So you have things like Swagger and all of its friends that allow you to generate documentation, that allow you to verify schemas, that allow you to handle version upgrades. We have monitoring. Now, kind of all of these things are good. Technology autonomy, so the fact that you can implement a client on a server in a totally different language, totally different runtime, that's a great thing. Now, unfortunately, these aren't here anymore. The one at the top is informative, I think, and it's something that people don't often think about in terms of a benefit of HTTP, and it is a benefit. Now, what I mean by a technical interaction model, if any of you come up with a better phrase for this, I'd love you to give it to me. What I mean is this. So you have your server, you have your client. The client asks the server, sends a request, and gets a response. That's purely technical, as in, there's no domain concerns here, it's just we have the HTTP protocol that's defined. It's HTTP 1 is easy, it's just a bunch of text. There you go, you get a bunch of text back with a defined layout, and that's it. You add your domain logic on top, and that's a good separation. It works very well. It means that we can build on top of that in any direction that we want. People often forget this aspect of HTTP and just take it as given. In the world of reactive systems, this isn't here. And so we've lost a lot. If we take away HTTP and start building a reactive system using some of the technology I mentioned before, this entire concept, this entire set of good things is all gone. And this makes me terribly sad. So, this is the trade-off. This fundamentally, I believe, is why reactive hasn't taken over the world. Because from a design point of view, from a data point of view, from a performance point of view, it is plainly better. But it's not taken over the world. It's kind of taken over chunks of the world, but not everywhere, not even the majority. So, one of the problems is because you don't have APIs, what you will do is pick one of the technologies and use it in place of an API. So you will often do things like adopting Kafka. You will adopt Kafka as a reactive technology, it's a message broker. You will adopt a message broker and use that as your API in effect. So you can throw messages into there, other systems can pull them off. And so that then means that Kafka becomes your strategic choice. You have to buy into Kafka for the long term. If it goes bad, tough. You've bought into that, that is where everything is going through. So, this is it now. So you have to make an upfront strategic decision. Now, if there's one thing I can say about microservices, it's that upfront strategic decisions are bad. You should not make them unless you have no other choice. Here it appears we have no other choice, and that pains me because it shouldn't be that way. Yes. So, if we have APIs and we get rid of HTTP, which is what I'm suggesting that you take HTTP away. Do we still have APIs? We need this thing, this reactive version of APIs. We need something else to replace this concept. Now, reactive APIs are effectively message APIs. That's what we're talking about. Reactive systems are message-driven systems. With some other stuff stitched around. So we need this concept of message-driven APIs. So there's some things that we need to define in terms of message-driven APIs. Now, if you've built a messaging system, what you'll find is that it's all domain logic based. So you, in your domain logic, will create a message that says something happened, or go and create me an email. That email will go off into Kafka. Someone else will pull it out of Kafka, send the email, another message will come back saying, I've sent the email. Now, that I've just described is effectively RPC, just implemented using messaging, and that's not a terrible thing. I would say it's not a great thing, but it's not terrible. But the problem with that is it's not reusable either. There is no reusable RPC over messaging type system. You're just throwing messages around. And that means that you can't remove one side of the equation. You couldn't say, well, we have an email service that accepts this message and sends another message. You can't easily remove that unless you actually understand what the messages are, what they mean, as well as what the interaction model is. So what do I mean by interaction model? Again, if you come up with a better phrase for this, please let me know. So we have our API on the left, my left, your right, and our client. And imagine we have this as our interaction between the two systems. So our client says, I want to trade X for Y. Reactive API comes up with a counteroffer and says, well, actually, I don't have that, but you can have something else now, or you can wait 10 minutes. And this guy says, yeah, fine, I'll wait. That's okay. Start sending me the data when you've got it. And so this then starts sending data. The client says, that's too fast. Slow down, send it a bit slower, and now, so you're overwhelming me. Now, this is the kind of thing that I want in a system. You know, this kind of coordinated kind of work between systems. You could do this with HTTP, but it would suck. Now, this as a system allows these to coordinate with each other in two different levels. One of them is at a technical level. So you saw that last one down the bottom, slow down. That's got nothing to do with the trade. Nothing. All that is a purely technical coordination to say, you're sending data too fast, send it slower. So that's a technical message. The other message is, well, they're domain level ones. So the fact that you're trading and you're coordinating the trade, that requires a deep understanding of what the domain is. So you have to actually be above the technical level. And so we've got a mix of these things. And it was that technical level of message that I found fascinating, because that's not often actually implemented. And so what we end up with is these domain level ones, which are kind of like, well, we'll do the coordination, do the trade between us. And if there is any kind of concept of slowing the data down, that's something that you have to implement essentially as a form of domain logic, which it isn't, but that's the only way you can do it. And so that then got me thinking, could you extract these common messages, these common technical messages, these common technical coordinations into something that's reusable, something that could actually form the basis of a new type of API? And so that's essentially what I think we can do, and what I think we should do. So if we can come up with these technical interactions, these different styles of API, then we can create these reusable types of API and then build things on top of them. We gain extra capabilities above RPC. And we can reuse them across platforms, we can implement them in various ways. So this is our different thing. So here, what I see is two different types of API. The first one is a negotiation. And that's purely domain-based. It's just you send messaging backwards and forwards until you come to an agreement. Once you come to an agreement, start to stream data. And at this point, the client is in control of how fast the data is traveling. So if we could implement this, we have a negotiation style protocol, and then a streaming protocol with back pressure. And so I think that we could do this. This is me looking back on what we've done with Muon. This is the problem, essentially, that we were trying to solve. I didn't know it 2 years ago. I had no idea. But this is what I've struggled towards. And so this is what I can only call reactive APIs, message-driven APIs, where I'm trying to recreate these things, but in a messaging context. So these good things from HTTP, you know, we want them. They're the best thing about HTTP. HTTP as a protocol is meh. It's neither here nor there. All of the things that we built about it, the ecosystem, that's good. We want that. That's what gives you autonomy between services. So that's what we want to recreate in a messaging world. And if we can do that, then we can move away from HTTP with all the benefits and none of the costs. And so this is, as I've been obviously gearing up to, this is what we've been trying to do with the Muon project, to try and understand and build message-based APIs, message-driven APIs, reactive APIs, if you like. So as an example, we have MongoDB. Who's ever used MongoDB? Some people. Good. Thank you very much. Now, one of the interesting things about MongoDB is that they recently added a reactive programming version of their database driver in Java. And so what that means is you can stream data out of the database so that it doesn't overwhelm your client. Now, if we were to use that in a microservice, that would be cool. And that's just really interesting. If we were going to a browser, we're presented with a problem. So we have data coming from Mongo through our service where we're probably doing some kind of data transformation, maybe aggregation. No idea, it doesn't matter. We've got data coming out through a service down to the browser. And what will happen is that we will start to buffer data. So we'll end up pulling data into here and it goes into the browser because the browser is the ultimate client here, not our service. So we're probably taking a load of data into the browser and rendering it. Ideally, we would stream that down into the browser too. And that would be the ideal way of doing this. Have you ever tried to do that? You know, you can do it. You kind of, well, say, could you do it in WebSockets? Yeah, you totally could. But you'd have to start thinking about what is the protocol of messages that you're going to send backwards and forwards. Because if you just flush data down the WebSocket as fast as you can, maybe that overwhelms your rendering. Maybe it's maybe the kind of thing that you're trying to do on the browser actually just requires data to trickle. Who knows? The point is, right now, if you were to implement this using WebSockets, then you would end up with a scenario where the data was moving too fast, and you would want to slow it down. You have that option now with Mongo, but only if you can send the signal back from the browser to your service to say, slow down. So, do you want to implement that yourself? I know I didn't, but effectively that's what we've done. So, that's fine, you could do that yourself. Imagine though, you had another data path, another database, another source of data. What are you going to do now? Are you going to have another WebSocket? Are you going to implement that same protocol in another service, talking to a different Mongo? You know, into the realms of this sucks. No, you don't want to do that again, surely. It was hard enough the first time, but you certainly don't want to do it twice. And you also run into the problem of browsers can only maintain a very limited number of open WebSockets at one time to a single domain. So you don't want to hit that limit. And opening multiple WebSockets to a single application seems silly. But it's hard to imagine another solution unless you get into a complex messaging protocol to manage all of this data. And that's the exact problem that I'm talking about. That just there is this idea of a complex messaging protocol that's actually purely technical, nothing to do with the domain. It's just you want to orchestrate getting data out of Mongo and stop it moving too fast. That's all. But by having multiple sources of data, suddenly this becomes hard. No, I don't like hard problems. I'm a very lazy developer. So this is kind of where I would kind of drop Muon in, because this is the problem. This is it really. So in terms of Muon, what you end up doing is you have an application, some kind of app code in some language. Right now we've got Java and Node and browser. We're adding more, which I'll talk about. But this is the kind of model that you want to do. So you have application code, you have some kind of API that represents a data architecture. So in this case, we want streaming with back pressure. That's what we want to do. And that's what this API will let you do, which is what I'll show you. Internally, we then have kind of messaging protocols and network transports and other kind of transformations and encryption and compression, all kinds of things like that. But this is the thing. This is your choice, your architectural choice. Yeah. So we have a protocol called Reactive Streams. Who's ever come across the Reactive Streams interfaces from Java? Nobody. Christian. Few people. So Reactive Streams is one of the most successful kind of community initiatives in the JVM world for the past bunch of years. Essentially what it describes is a set of Java interfaces that allow different functional reactive programming libraries, streaming libraries, to connect to each other and send data between each other with back pressure signals. So you could connect an RxJava kind of library and Mongo, for example. So Mongo implements this as an API. So you can talk to Mongo, get hold of a Reactive Streams publisher interface in Java, attach RxJava to it, and transform the data on the way out as a push pipeline. Very nice approach, works very, very well. The actual interfaces are very simple. There's three interfaces, and all they do is define a set of messages, in effect, that go between the two implementations. So you have a message which says, subscribe to this data, and then another one that says, I'm ready for more now, so give me more data. Others that say, the data is finished. Another one that says, some kind of error happening, disconnect, and we're done. And so these are the kind of messages that you're talking about purely in the JVM. Now, what I did, I looked at this and I thought, these are messages. You know, it's a Java interface, yes, but these are messages, they're signals. If you were to convert those into messages, then what you would have is a messaging protocol that you can send across the wire that actually describes a solution to this problem, which is, how do you implement back pressure? How do you allow a client to control how fast the data is flowing? We have our messages, just pull them straight off the interfaces. The benefit of this is that in the Java world, you can then map these onto the interfaces. So if anyone has a Reactive Streams implementation, and there are many, then you can just plug this in and we can start to talk network at it, which works very well. So in terms of Java, this is what you end up with, something like this, where you create yourself a Muon object, which I'll show you in a demo at the end. You create a Reactive Stream server. You then do something to get hold of this guy, a publisher. So this is a Reactive Streams publisher. And then you just expose it on the network, give it a name. And that's it. So from that point on, if you want to connect to this data, obtain this data from Mongo, then you can from any implementation, whether it's Java or whether it's Node, browser, whatever. From client, your connection would look like this. And you would end up with the data coming through as a push from Mongo, but controlled by this, controlled by the Node client. Now you can't actually see the control in here. What this is doing is every 10 items it just requests more. There is a more complex implementation you can use to kind of give you more fine-grained control, but that doesn't fit on the slide. But most of the time, this is actually fine. And so there, what you end up with is a question, well, if we could do that, do we still have two WebSockets? In the Muon model, no, because this becomes an issue and we want to get rid of that. So what we end up with is something like this. We have one WebSocket, and all of our messaging can go through that. Because fundamentally Muon is all about messaging, the Reactive System is message-based. What we did in the Muon world is to include enough information in the messages that they can route, they can be transformed, they can be proxied. And so that's what this guy can do. This has a WebSocket server here, and then on these interfaces it can be anything you like. So generally the systems that I deploy using Muon tend to be AMQP, because that was just the first one we used. But it could equally be TCP, Kafka, gRPC, anything you want to in terms of network transport to the other services. And the important thing is you can have multiple subscriptions open, they're all multiplexed over this, and then head out to the appropriate service. So it handles all of this technical interaction problem for you. So in a browser, it's slightly different because you have to initialize it to connect to a remote WebSocket. I think we've wrapped it up reasonably nicely, so you end up doing this. The code is actually the same apart from the initialization. All that does at the top is to create a WebSocket connection and then sit our API on top of it. So from this point on, you would connect via that route that I just showed you. So via the gateway, to the service, to Mongo, data would flow all the way down to your browser as a push, controlled by the browser. How are we doing? Are we there? Wait, there's more. Have you ever, I don't know if you get the adverts over here, but certainly in the UK we get, do we have any Americans in the room? No. No, we don't. Okay, so we have an advert that's very obviously from America, which is about Pinelli pens. And so you just end up with this advert on the TV and say, wait, there's more, you get these Pinelli pens. So, anyway, there is more. So I've shown you one API, Reactive Streaming. Now this is one form of messaging interaction. It's a good one, it's a great one, you know, it's very useful, but it is just one model of interaction that you could use. There are others that we can implement, and we've implemented others. And I don't have time to go through them all in detail, in sufficient detail for them to get them across. But there are other types of API. And I think that's the important thing is, what I've not shown you here is things like you can request a service to show you all of the APIs that it has, all of the endpoints that it has. You can request that it gives you the schema information. You can do other things like that. So we've gone through and tried to address each one of those items in terms of this is an API. We can route across a variety of things. The actual model is fairly, it doesn't care that much about what it's routed. As long as you can get a message from service A to service B, anything can be used. So right now we've got AMQP done well, TCP done okay, gRPC in the works, and Hazelcast as a nice idea. Okay. Completely infrastructure agnostic. I don't care if you run this on Kubernetes, Cloud Foundry, or your laptop. No, it shouldn't matter. It really shouldn't. And so I've seen many things that like to call themselves microservices frameworks that say we only run on Kubernetes, which I think is a terrible error. You'll notice I didn't describe this as a microservices framework. I used to, but this is about communication. This is about trying to give you better options for communicating between systems so that you as developers can make better design decisions. At the moment, you're tied into HTTP because the other options are strategic choices, and that sucks. So I want to get you away from that, to make this as easy to use, as easy a decision to use as to use HTTP is. It's not there yet, totally accept that, but that's where I want to be. If you want to contribute, I am very, very happy to talk to people who want to contribute. So there's a variety of things that you could help with. So there's adding a new language. Oh yeah, I want to talk to you about it. So one of the things that we are doing, which is, we want to add new languages that we're implementing in Muon. One of the things I noticed though is that creating a new implementation, it takes a fair amount of dedicated effort. You know, probably one person who knows the language and knows the model a couple of months to fully implement, which is significant because most of the time you don't have that much time, so it could be 6 months to fully implement something. So what we're doing is to take Rust, the language that I obviously love, and then we're taking Rust and implementing Muon as a shared library with a C interface, so that you can then wrap other languages around that. So if you want to be involved in that effort, I would love to talk to you. If you're more interested in different interaction models and kind of understanding and implementing those, I would also love to talk to you. I am doing this kind of series of talks around various places, and what I'm really looking for is feedback on ideas. I'm trying to find new things to implement, trying to bed things in different ways. So please do ask me and request things. So, I will show you a demo, just to show that this isn't total vaporware. That worked? Oh no, that totally didn't work. I'm looking at something different. Yeah, there we go. Okay. Right, just to show you an aspect of what I just talked through. So, if you imagine we have Java server, Reactive Stream server. We want to get that data into the browser. There's a server push, but controlled by the browser. That's the kind of problem that we want to do. So I won't show you a version with Mongo involved, purely because I haven't written it. But if you want to, we can probably do that afterwards. It was not terribly complicated to do. So here we have the API that I showed you. We have some kind of publisher. This is a publisher implementation. We have a Reactive Stream server that we're creating. we're creating something called TikTok and passing our publisher in. So whenever someone comes along and connects over the network to this endpoint, then they'll start to get data, they'll subscribe to that data. Now this particular data I'm generating in a thread, so I've just got a Java thread here that's pinging away every 2 seconds and sending a simple message. So this will come through as a JSON packet with one key, one value, with value at the current time. So we can use our CLI, do a discover, see what service is running. So this is currently hooked up over AMQP, and the reason you see a pause is we have to do a discovery of what services are available. In AMQP, there isn't an easy way of having a central server, apart from the AMQP server itself, that you can put information in on what services are available. So this is currently using a broadcast exchange, and each service is announcing itself every couple of seconds to say, I am here. So the pause is the client waiting for that information to come in. So you can see we've got several services there. If we look at, say, Hello World JVM, we can have a look at what information it's got. So part of the API thing that we're talking about is we want to be able to see what this thing can do. So this is the introspection report. So this has these types of API available. So simple RPC, Reactive Stream, which is the one we care about. We have the various blocks. So this does have an RPC endpoint there. But for us, it has our TikTok endpoint. So if we do just to prove it's sending data. Hello world, JVM, TikTok. Then this will connect. Again, this is over AMQP. Has a pause to do a discovery, connects in, and then starts to receive data. Every 2 seconds you get a push. So this client is doing the same thing. Kind of the code that I showed you on screen. If you were to look inside this client, it's actually written in Node. So it's using the exact same code that we saw before. So leave that running there, quite happy. Now I have the browser version. So I've got a very simple one here, which is we have a version of Muon that's been packed using Browserify, if you come across that. And so it just exists on disk in there. Now I want to take that and do a subscribe, like this. So if I run up my server using something, simple HTTP, so I think it's Python web server is what we use in the end. What this is doing is connecting to the Muon gateway service I mentioned, which if you look, was actually in our discovery. So this is running there. It's again a node server. It's just a simple message router. Takes WebSockets coming in and then connects to the service that's mentioned in those WebSocket requests and just exchanges data along it. Doesn't do anything else other than that. So what we should then see is if we open this up. So if you remember the code, it doesn't do anything else other than do a console.dir, put that data out. So we'll see it in the console, which is what you can see here. So here we have server push from a fairly straightforward server that's using a standard interface in Java. And we've actually got multiple things connected to it at the same time, receiving both the data out. So it's doing it's not a broadcast, it's multiple things subscribed. And we have our browser connected over WebSocket. We can have multiple browsers connecting via the same thing, getting the same data if we wanted to. So, quick demo, this is real. This is actually a thing. You can have reactive streams as an API, as a class of API across a network, across languages. And this isn't the only one, we can do others. So, yeah, I'll be happy to show you more if you're interested afterwards. All of this code that I'm showing you is available on GitHub, if I have that available. No, I don't. Oh yes, I disconnected. Anyway, that's the URL. If you go to GitHub and Muon core, there is a repo called Muon Workshop. All this code is in there, along with a bunch of other demos that you can start to look through. So yeah, if that's of interest. Just a final, that's not good. Final thing, do it here. Tomorrow I'm doing another talk. It's not the same talk, honest. This is a lightweight Java Munich meetup thing. The first third will be the same, but I'm going to be talking about a different API. So not Reactive Streams, I'm going to be talking about the event log API, and then some kind of system that you can build on top of that. So some of the benefits that you can have. So it will be a different kind of a subject. So if you're interested in learning more and seeing another one of the different types of API you can implement, please come along tomorrow. No idea where it is, but you'll find it on Meetup. Thank you very much. Have you any questions?
Thank you, very inspiring. Have you had the chance to port your source code to Java 9 JSON yet, or not?
No, I haven't looked. So it's a pertinent question because the Reactive Streams interfaces have actually been adopted to Java 9 or Java 10. Can't remember. Anyway, the Reactive Streams interfaces that I'm showing you, they are on the path, at least, to being pulled into the JVM and standardized. So if you do any work in the JVM, these interfaces that I'm talking about will be a fully standard part of Java. But the quick answer is no. I'm pretty sure things work because I actually use Java 9. My laptop has Java 9 as the JVM, but it might be running in some compatibility mode or something. I'm not sure. There we go. Any more questions? Come on, guys, I'm friendly. Let's have a chat. Who loves HTTP? Well done, that man. Okay, well, thank you very much. I don't know what the plan is now. Is there a plan? I plan on drinking some beer.
Yes, that's the plan. Stick around. So I totally assume there will be some questions because I believe this is there you go. It just took some time.
Thank you. I thought I'll be the last one, so thank you. Thank you for your presentation. And I have a question regarding the clients. You consider the CLI client and the browser. But I was waiting for you to mention the mobile applications all over the presentation, but you didn't.
The what, sorry?
Like mobile applications. Anyway, service exists for browsers, probably also for mobile applications also.
Mobile. Yeah, so good question. So my response would be Muon Java, the Java implementation, as far as I'm aware, last time we checked, it runs fine on Android. We have no solution for iOS, simply because we started in the server side, we started as this is a microservices framework, and it's only in the past year maybe that I've thought of it as something else. And yeah, in terms of mobile, it's certainly a big target now. Now that we've gone, this is better APIs, which is effectively what I'm talking about now. It's certainly essential, but not something that I've addressed. Purely from a capacity point of view.
Okay. So you think it would be perfect if we have a client for iOS and also for Android?
Yeah, totally. I certainly want to, but we'd end up having to port to Swift or to Objective-C or something. I believe, so I'm currently pinning a lot of hopes on Rust in terms of implementation because it runs on so many targets with such a lightweight kind of runtime. So I believe it can run on iOS too, so it can run on Android because it just compiles down so nicely.
Okay. Thank you.
So yeah. I mean that's the discussion answer. I don't have a shiny, this is an awesome sales pitch type thing. But yeah, it's certainly something I would love to do. But in terms of time, it's not something we've got to do yet.
Yes.
So you're using AMQP there, and maybe RabbitMQ, for example, or
yep.
how do you transfer the messages? Yeah. How do you handle loss of messages due to network partitioning, for example?
So my opinion on network partitioning and loss of messages is that they always happen. And so going back to here, wherever it's gone, totally near somewhere, here. So this is the model. And you talk to the API, and ordinarily, when you're talking to an API, this is a messaging API. And so you'll send a message from your application code, and it's up to your application code to handle the failure cases. And sorry?
So you mean resilience? You have to.
Yeah. So the resilience question. Now, my view is that that's a hard problem. You know, essentially talking into kind of the realms of CAP theorem. So if any of you not come across CAP theorem, I recommend it. So essentially what it describes is building systems either in assuming that consistency is real, or whether actually availability is the way to go. And if a partition happens, you have to make a choice in any part of the system as to which one of those things you want to kind of go for. If you build a consistent system, which is a good choice, then whenever a network partition occurs, what you have to do, what you must do, is one side of the partition has to die. It has to shut down in order to maintain the consistency of the data on the other side. I don't like that in terms of building highly distributed systems, because partitions will always happen, and so you'll end up with massive churn. And actually, it turns out it's a lie anyway. You know, data is inconsistent, and it always will be. So you should assume that failures will happen. Now, the reason I'm mentioning that is that the network transports. Yeah, you saw me demoing using AMQP. This is actually totally pluggable. So I could show you probably it running on just TCP between services. So this will just connect using straight TCP. Now, TCP is great, but again, you know, failures happen. We have a network. So actually, this, for me, is the guide that matters. So this is where you implement the wishes of the API. So in case of reactive streaming, we have, I want to subscribe to this. What happens if a network partition occurs? You know, that needs to be bubbled up to here in some way that makes sense. So in this case, what it does is monitors the communication, makes sure that the communication is flowing. If it's not received anything with a certain while, including some kind of keep alive, it informs the API that something's died, you need to deal with it. So that's a very long-winded way of saying messages go missing. Generally, the protocols will attempt to maintain what consistency they can. But if it all goes dead, then it all goes dead. Your data's missing, it's gone, deal with it.
Thanks.
Okay.
Thank you for your talk. I don't really get why HTTP API is fragile in the era of Kubernetes, of another Docker orchestration systems, which allow me build very resilient systems based on HTTP API. I can run hundreds of my brokers, which are available through load balancer. And why do I need another beast like this in my system?
So it's a good question, and one that I certainly get often when I'm saying to people, HTTP is your enemy. Fundamentally, it's if you don't mind, it's going back to this problem. So if you have 10 instances of product, you have a request that goes through to here. If the service that you are requesting goes down halfway through processing your request, that's the same thing as if you have a network partition. This service doesn't know the difference between service failure and network partition. And that's an important thing to understand. From the point of view of this, they are identical. Something has died. And the problem is that we have our services in a web that's increasing the failure rate. So, kind of going back to my calculation, you're saying essentially this. You have your services, you have 5 nines uptime on your services because Kubernetes says so. And I believe you. I believe you have 5 nines uptime. totally. But unfortunately, you have to believe me that this is what you actually have. You know, because you have a multiplication of failure that will happen. And if you look at your real uptime, actually, it's probably more like this. Even though each individual service has 5 nines, your real system uptime isn't that. It simply can't be mathematically. So this is a problem, but also there's the problems of, you know, your performance. You think it's good, probably, and I'm sure it's adequate. It could be a lot better if you arranged your data differently. And so this is where I kind of start to make the argument, you know, we think of microservices, the first thing that people do when they break them apart is say, how can they communicate with each other? I would say that's the wrong thing to think about. It's, what is my data and where should it go? You know, that's the real thing. Data has always been the hard thing with system design. Always, it always will be. Communication is actually fairly easy. But kind of your data architecture is the real thing. And this has created a data architecture that frankly sucks. Because if I want to join data from this database and this database and this database, it's really difficult. And the only reason you've done that is because you've bought into the HTTP REST resource kind of approach across your system. And again, I'm not saying it's bad. I'm just saying if you've ended up designing your system like this because of it, well, actually, maybe it is bad. You know, it's done bad things to your mind. So yeah, I mean, that's my argument, that's my opinion. I'm not saying it's gospel, although I am on the stage, so that gives me certain power. I'll leave it there. Are we done? Should we get beer? I'm looking forward to a beer. Okay, thanks guys.
Thank you.